Hello, everyone. Welcome to our Twitter space today on all things ZKML. We're waiting on a couple of speakers to join us, so we're going to get started in just a couple of minutes. All right, looks like we've got everyone here. So again, welcome to our conversation today on all things ZKML. I'm Stephen Smith from the Worldcoin project, and I'll be hosting and facilitating the conversation today. We're going to make this very casual and kind of open. ZKML is a very interesting and timely topic, of course. There's a lot of interest in the topic. You see it headlined at a lot of conferences. There's a lot of sessions on it, et cetera. So today we've got like a great set of participants from some of the leading projects in the space, and we're very excited about it. I think what we should do first is just kick off with a quick round of intros. Let everyone tell us a bit about yourself and what your company is focused on right now. Jason, I believe you're in the call. Jason from ZKonduit, you want to kick us off? Just give us a quick intro and tell us about yourself and what your company's focused on.
Yeah, thank you. Thanks for inviting me. I'm Jason. I was a math professor and built various technologies. Our company, ZKonduit, what we focused on is building a compiler that lets people turn arbitrary deep learning or machine learning models, AI models, into zero-knowledge proofs. So you can take an ONNX file, which is a serialization format for an ML model, and you can hit it with our compiler, produce a prover and a verifier that's verifiable on chain.
Very nice. Let's see. Ryan and Daniel, are you on from Modulus Labs?
Yes, sir. Hello, Stephen.
Hey, how you doing?
This is Daniel.
Hey, good to see you. Good to hear you again.
Yeah, hello, Stephen. This is Ryan.
Hey, Ryan.
We're both here, Stephen.
Cool.
That's right.
Want to make sure that the whole party was here.
Right.
Absolutely.
Sounds good. I like it.
Yeah, I guess a brief intro. Hi, everybody. We're Modulus Labs, or Daniel and Ryan specifically, but you can call us Modulus. And we are working on a custom zero-knowledge prover built from the ground up to support AI operations. So it's all towards the kind of purpose of supporting large and sophisticated AI models to be run in this accountable way. And I'm sure we're going to dive into what all of that means. But super psyched to be here. Very cool to be surrounded by so many friends.
Ooh,
Go team.
Very nice. So we also have DCBuilder from Worldcoin. DC, you want to give us a quick intro? Kind of tell us what you're focused on?
Yep. Hello, I'm DC, and I am a research engineer at Worldcoin on the protocol team. And yeah, I've been recently researching ZKML, and I've given a few talks about it, and I'm really excited to have the discussion with you all today.
All right, very good. As I mentioned, I'm Stephen. I'm also from Worldcoin. I work in the protocol area and across the company on a few other initiatives. Do a little bit of research here and there, mostly just anything they ask me to do for the most part. Just one bit of housekeeping to let everyone know. We're going to try to reserve a few minutes at the end for audience questions. So if we've got a really good crowd, it looks like. So if you do have any questions, just ask those in the Twitter thread, and we'll do our best to get to those at the end. I'm most likely going to have quite a few myself as we go, so I'll try to make it a little bit interactive, but give plenty of time for our guests to talk. So look, I think it would be really good to start off with a little bit of a level set on what ZKML is. So most people that are in the space and will watch or listen to the recording probably have heard of ZK or zero knowledge tech, and most likely ML or machine learning, but they may not really know what ZKML actually is or what it's targeted at. So DC, you want to kick us off? Well, definitely everyone wants to chime in, but DC, you want to kick us off and just take a few minutes and give us an overview of what is ZKML?
Yeah, ZKML stands for Zero Knowledge Machine Learning, and it's essentially the creation of zero knowledge proofs of these computations that happen inside of a machine learning model. So to boil those two concepts down to its constituents, so zero knowledge stems from zero knowledge cryptography. Zero knowledge cryptography is an area of cryptography that allows us essentially to prove computation, and it also allows us to essentially hide parts of the computation to a verifier. And the sort of standard definition is that we're able to create a proof to a verifier that some computation happened correctly according to some definition of that operation. And we're essentially able to verify that operation in a lot less computational steps than it takes to actually perform said computation. So for example, maybe many of you have heard of zero-knowledge rollups, which are these scalability solutions on Ethereum. Think Starknet or Scroll or ZK Sync. So what these are doing essentially are sort of proving that these blockchains executed transactions correctly, and then a verifier can verify that these indeed happened correctly. And so the verifier can update the current state or his current representation of the state without having to compute all those transactions themselves, and thus saving a lot on execution costs. And so in the context of machine learning, we're able to prove to a verifier that the prover ran some machine learning model on some input and created some output. And we can prove this computation end to end. And we can also hide parts of this computation. That's the general gist or definition of what ZKML is.
Okay, sounds good. Jason, Ryan, Daniel, anything else to add? Just a general overview of ZKML and what it means, how you view it?
One thing that I find really helpful as a way to understand what it's doing is if you're familiar with a digital signature, like the signature used to send a transaction in Bitcoin or Ethereum, a ZK proof is basically you take the signature function and you replace it with an arbitrary function. So it's like programmable signatures. And the trust model is very similar. That is, when I get a signature that someone signed to send a coin, I can believe that they really signed it. They knew a secret, they knew a message, and they produced a public output. And the trust that we get from ZKML proof is of a similar security properties.
Very good.
Yeah, just wanted to add and say for folks who are maybe a little less familiar with the machine learning paradigm, so the whole idea here is you can think of machine learning models as almost like this factory type thing, where your inputs are, for example, like images of some sort that you might want to classify, maybe cats and dogs, and then the output of this factory should be basically a 0 or 1 based on whether it is a cat or a dog. And so inside this factory, you have a bunch of kind of machines, each of which are operating over these images, and basically the state of the machinery is the architecture of the model. So like which machines come first, what are they doing to this image, and then the actual kind of knobs and things that you're tuning inside the machines, those happen to be the parameters to the model. So these are the things which are being learned when you train the actual model or when you're building this factory from the ground up. So in zero-knowledge machine learning, one of the cool things that you get is that you can effectively validate that a particular factory was used with all the machinery that everyone cares about and agrees on, and that some set of consistent parameters were used, so some sort of consistent tuning for these machines were used without revealing the actual ways that the machines were tuned, which usually turns out to be the IP that people care about. And so that's where the zero knowledge or the hiding property comes from.
Oh, very good. To zoom out, because I don't have a strong background in machine learning, is it like a summary to say that, with the machine learning, you have a model, it has to be trained. ZKML allows those models to be trained on what people might consider sensitive or personal data. Could be like healthcare related data, for example. Is that kind of, and again, super high level in a nutshell of what ZKML helps us achieve?
Yeah, that's a great question, Stephen. ZKML can refer to basically ZK inference or ZK training. Right. In ZK inference, the statement that you're proving is that some machine learning model, which has already been trained, and this part you need to either trust or test, is actually the one which is being run. Whereas in ZK training, it's more that some machine learning model is being trained using a specific algorithm over a specific data set. So if you do care about basically the fact that, for example, Midjourney's models are not being trained over Getty images or things like that, then you would need something akin to basically ZK training. But basically in the other case, it's not actually about the sensitivity of the data, and it's more about the fact that a consistent model is being run.
Okay, makes sense. Yeah, thanks for that. Yeah, again, the split between inference and training, I think when we lump those together under one umbrella, ZKML, so like ZK training, I like how you phrase that. That's super clear to me, what you're referring to in that case. All right, look, so we've got a pretty good level set, and hopefully that was informative to everyone. I know it was for me. So with that kind of as the background, I want to shift gears a little bit, and it's really a question for all, but I'll start with the Modulus Labs team. So what are some of the specific use cases for ZKML, and why is it such a hot research and development area at the moment?
Yeah, we can answer those questions in reverse. I think, or I guess we think that it's such a hot area because these are like very exciting letters to put together. ZKML, this is like
a lot of letters.
Exceptional,
no vowels,
exceptional, really strong sound. But I guess earnestly, ZK is this, and maybe Jason can add some color here too, but ZK is this holy grail of cryptography, right? The kind of security standards, yet absolutely perfectly preserved. It can be verified just forever, right? Without kind of an additional need for interaction from the prover. This is all very exciting on the cryptography side. And of course, on the AI or compute side, This is like the infinite expressivity, right? Or perfectly like creative cauldron of the compute revolution that we're experiencing now. So getting to marry those together is very exciting. I guess briefly on use case, and there's a lot to dive into here, of course, we can see this paradigm applied to all kinds of things that are already very exciting in the Web3 context and potentially even more beyond that. And so I guess for Modulus Labs, we really started by building what we thought were pretty fun, but maybe a silly proof of concepts across DeFi, gaming, NFTs, and trying to apply this idea of accountable machine intelligence onto these existing paradigms that are very exciting in crypto. But I don't know, we can dive deeper here. Maybe we should start with a high level overview first. Jason, I don't know if you want to add something.
Yeah, sure. Let me jump in. Something about the high level overview that's a little kind of like the bull case. I think ZK is sometimes thought of as one of these, as you said, big crypto technologies that can steamroll over a lot of other technologies. So a lot of complex constructions that we can build now using signatures and using other cryptographic primitives, we probably are just going to end up ripping them out and replacing them with more general purpose zero-knowledge computation. And then we're seeing the same thing happen with AI and machine learning, right, where people suddenly are ripping out complex SaaS solutions and complex business logic and just replacing it with a language model or some other kind of capable model. And the bull case here is, as you said, with the alphabet soup, right? We can take these two steamroller technologies and combine them. Of course, there are also limitations to that. But I think that's one of the reasons people are so excited about it.
Cool, very good. Yeah, it is a super cool acronym, by the way. So it'd be almost impossible to form it into a word, but ZKML really resonates. So what about use cases, like real world concrete examples of how this is being used or potentially could be used, medium to near term, in the future?
Let me jump in. So one of the ways to think about the use cases, I think, is to realize that in an old school organization, a Web2 organization, a software company, or any other company, a lot of machine learning, a lot of AI is getting built into the business processes, right? You can't run Uber without ML. You can't run a recommendation engine. You can't run Amazon without ML. Increasingly, you can't even run a government service without ML. And with this sort of Web3 mission, we're trying to convert these organizations into organizations that can run on-chain and can be on-chain. And so the big picture is we're going to need a way for these on-chain organizations to run machine learning models to understand the outcome of soft judgment. So yeah, that's the big picture. And then the applications are things like games, as I mentioned, identity is, of course, is close to the heart of WorldCoin, even finance, other things.
Okay, how about you, Daniel or Ryan? What are some top use cases that come to mind when you think about ZKML?
Yeah, well, I mean, we can start, close to home. I think I see one of the listeners is Mosaic. I think they're using AI algorithms to try and maximize yield for their customers, but potentially folks like them and other DeFi protocols who want to implement AI algorithms into their calculating how they rebalance their pools, implementing more complex strategies. They may want to show their customers that there's absolutely no way for them to tamper with the results of those AI decisions. And in those contexts, it might be very beneficial to implement almost a ZK badge of approval or a ZK promise, right? In that kind of earlier factory analogy, it's like the operator of the factory throws away the keys, right? They can't really mess with the internal workings of that process anymore. So that's on the DeFi side of things. And I think we're just starting to see more advanced algorithms being brought into that domain right now. And of course, there's also use cases in gaming, right? Not to show our own project too much, but we built a game recently that pit an AI model against the human playing team, the world in this case. And we were able to implement a betting mechanism on top that relied on the security guarantees of ZK here, in basically saying that the AI model powering the game agent here could in no way be secretly swapped out or surrender to the whims of the operator who might be biased to weigh the success of any given game one way or another. And so, we're getting to work with really cool folks like AI Arena in leveling up the kind of guarantees that they can make to their customers on the AI outputs that might be important in their in-game economies. And of course, there's some really exciting stuff happening in the identity space with being able to operate high integrity analyses, AI-powered analyses over user biometric information without them ever losing custody of that process or their own data. But maybe DC can add some more color to that, or yourself, Stephen.
Yeah, so so DeFi is great, gaming is great. I think there's some ID, of course, is great. I think there's some incredible use cases. And I look at healthcare, right, which that has a potential to affect so many people and improve their lives. And I see one example being like probably some of the most private data people have are like their healthcare related data or genetic data, for example. But there's a lot that can be learned and inferred from that with a really intelligent model for disease prediction, for example, things of that nature, where it'd be great to run models over that sensitive data to be able to benefit just everyone. It's almost in that case, Web3 becoming an on-ramp for what's traditional Web2 type things, or even Web1 type things, or maybe not even web-centric type things. So that's super exciting to me. DC, anything to add? Like any use case we didn't mention that it resonates with you?
I think we talked over most of the most prominent use cases, the more obvious ones. For me, like a good way to think of ZKML or like its capabilities, and as with respect to like blockchains, is that blockchains are inherently really like computationally constrained, and therefore they're not really powerful in terms of computational power. And since ML algorithms are quite the opposite, they're extremely intensive in terms of like how much computational power you need for inference, though, but it's still quite hard to scale these services. And so something that ZKML enables, in my mind, is just bring any of these machine learning computations on chain and then prove the outputs of these computations on chain without having to run them on chain, which is like this overarching theme that we've been talking about with all these use cases. As more and more ML computations become relevant or useful in different contexts, whether it's like identity, games, financial, as there's more and more of these, there will be an inherent need to bring them on chain, and thus something like proving these results using zero knowledge machine learning might become relevant. So that's like an encapsulating framework that I use to think about it.
Cool, very good. Excellent. Yeah, thanks for all that. Great use cases, pretty exciting. Quick reminder, if you do have any questions as we're going to continue the conversation, be sure to drop those in the Twitter thread. Be happy to answer them. We should have a few minutes at the end. So I want to shift gears a bit again. So we talked about what ZKML is, some of the use cases that we see. And based on those use cases, what's the current state of development? What can we do to address some of those use cases? How close are we being able to do that? Or are we already able to do that in some cases? And I'll start with Jason. Let's start with you on this one.
Yeah. So I would say that the state of the art is moving extremely fast, right? In the past 9 months for us, I think we've gone, to give you a sense, like the first kind of proof we did 9 months ago was sort of took more than 100 gigabytes and took, I don't know, half an hour or something. And now we can do MNIST in less than 2 seconds and less than a megabyte, or less than a gigabyte. And then now we're moving on to models of the next scale that are in the few 100 million parameter, so maybe half a gig type size. And so we've come maybe 8 years of development we're kind of going at a pace of about a year a month in terms of recapitulating the history of ML. And I think that we're going to see what ZKML models can do, whether the ones made by Modulus or by us or by other folks, are going to catch up to the state of the art in general AI, general ML, as soon as the end of the year. Maybe another year, we'll see. But that lag is going to get very small very soon. So I would encourage everyone who's on the call, think about, if you didn't have to worry about performance, what cool applications would you make? Now's the time to think about that.
Excellent segue there. And Daniel and Ryan, I'd be interested in your thoughts on this as well. Like, how close are we being able to address some of these use cases? We're going to talk about performance in the next little segment, if you will. But I'd be interested in your thoughts on how close we are currently to being able to address some of the use cases that we went over.
Yeah, I think since we started, we've always, maybe this is just the privilege of coming from primarily before crypto as an AI background, but we were just always excited about bringing as large of a model as possible on chain and, just imbue the chain with as much kind of machine creativity as possible. I think a good example of this is when we first started, our first proof of concept, our first project had about 70,000 parameter, 3-layer feed-forward neural net, anemic, tiny little model. Our latest project is, I think, about 3.7 million parameters. And our upcoming project, which is a ZK-GAN, or a model which outputs pixel art that is verifiably authentic, is going to be even larger than that. And certainly that can be larger in both the size of the model itself, but also in terms of the volume of outputs and what's actually being brought on chain. And so I think in a very practical sense, so maybe mirror what Jason's saying here, we are seeing more competent projects being brought on chain, maybe with a slight lag again, but nonetheless, that lag is getting smaller each day. And certainly we like to think that the kind of proving improvements that we're bringing on the zero knowledge side, what we spend most of our time doing, will be another step change in the right direction within the next year or so. So it's definitely very exciting. Look forward to bigger and more exciting models in your on-chain services soon.
Okay. All right. Appreciate that. And DC, you did actually and recently published an excellent article on the like a survey of ZKML, the landscape, some of the things we're touching on today around use cases. So what do you see at the current state of development? Just summarize it in your own words based on a lot of the research you did.
Yeah. So for me, I wanted to understand what are the current limitations or bottlenecks and go down from there. So I took a look at the current state of the art of ZK, like what proving systems are good for these specific computations that we're proving inside of ML. I took a look at different toolings, whether it's Ezekiel from JSON and ZKonduit, and some other like libraries that do some sort of like transpilation from ONNX to CIRCOM and whatnot. And I also really enjoyed the article and blog post from Modulus Labs, The Cost of Intelligence, which sort of surveyed which proving systems were fit for differently sized machine learning models. And I think that even though like we're at a really early R&D phase, the developer experience is improving rapidly for using zero-knowledge proofs to tailor them to a specific use case, let's say ZKML. And with the current developments of both better developer tools for creating proofs with better hardware that can optimize specific computations that are happening inside of zero-knowledge circuits, and just in general, more mindshare and more people thinking about problems within this domain, the use cases and just the overall usability of ZKML is improving rapidly. But yeah, I think we've mentioned most of the things that are happening currently.
Cool. Very good. And yet another really good segue. You mentioned that Modulus Labs did an excellent article on cost of intelligence. Is that what it was? I believe that's what it was titled. But essentially it included like a lot of great benchmarks. So shifting gears into, we talked about use cases where we're at today. What needs to happen next? And if you can, for Modulus and ZKonduit, share maybe like your near-term roadmap. If you're not comfortable sharing it, that's okay too, because I know a lot of times this is still a research frontier for everyone, and they're wanting to figure a few things out before they publish. But in general, what needs to happen next? What do we need to improve upon to make some of these use cases more of a reality? And Jason, I really liked your comment on don't worry about what can be done. Just think about the use cases for ZKML and count on people figuring out how to accomplish it. So yeah, so Jason, I'll kick it over to you. What do you think? What needs to happen really next to realize?
Yeah, sure. So we're really at a phase, as I said, the progress is happening very fast. I think we're at a lead bullets, not silver bullets phase, where it's just engineering work. We don't need any more theoretical breakthroughs. We have to apply the ones we already know about and do optimizations. I'm pretty confident that we'll be proving as big a model as you like, maybe a bit short of GPT-4 because we don't have access to the weights in the pretty near future. So I think the most important thing is applications. So I think some of the other speakers on the Modulus and Worldcoin, you guys are better than we are at thinking about applications. We're lower down in the stack, and we like to think of just make a compiler and let other people think about applications. But to me, the big question is really, we've talked about some sort of vague applications or kind of proof of concept stuff that we're thinking about, but I really think that the people on this call, the sort of growth hackers and developers, are going to come up with the best use cases. I think the best use cases of ZKML have not been discovered yet, and that opportunity is still out there. So I think what we really need the most is that good thinking about how this can fit into a larger ecosystem, how this can fit into society, how it can benefit society.
Oh, excellent. Yeah, we mentioned a couple times the blog post you folks did over at Modulus on cost of intelligence. So I'd like to tie that into what does your team believe that needs to happen next? What are some things we need to research out and improve, can be done or improve upon? Like, what would you say top of that stack?
Yeah, I think that concretely, the number we try to remind ourselves is, let's say it takes a second to run a model right now. It takes on an order of thousands of seconds to prove that model, right? And that's improving very quickly. But we are laser focused on bringing that down 100x, right? Until we hit the kind of 10x range, or maybe, God forbid, sub 10x range. We think that's when really very exciting use cases design space just expands so much more. And for Modulus, we're a little longer term here. We're very excited for, obviously, the tooling side to get a lot better. Ezekiel is an incredible step in the right direction there. But we want to make sure that the step after that, the proving step, is also going to be supportive of these expressive models that are only going to become more populous and more capable with time. And that's definitely something we focus on, as well as, of course, totally right on the money there, the use cases developing these, especially like high volume, high intensity, sophisticated models, the stuff that got us excited in the first place, making sure that they have a home here in Web3 and that we can bring the culture of decentralization as well as permissionless software to what I think will be the most exciting computing paradigm of our time, AI. It's a total privilege to get to live in this intersection, and the water is fine. Y'all should come and join. There's no piranhas here.
I like how you said that. And I love the mental model of the intersection of ZK and ML. Like, I worked at the electric coin company for the last 3 years prior to joining Worldcoin. And of course, we're all about ZK, right? Some of the pioneers of ZK tech. But just the intersection of these two technologies is incredibly exciting. And in terms of like where things need to go next, I know we have, and I'm going to kick this over to DC to explain, like one of our use cases involves being able to do things like in a mobile environment, which means that we've really got to optimize for that use case in general, being able to do some of this on mobile. But DC, you want to talk about one of the use cases that's on our research roadmap in terms of doing things on a mobile from a self-custody perspective?
Mm-hmm. Yeah, so Worldcoin is building WorldID, which is a proof of personhood protocol that's privacy preserving. And part of WorldID is just making zero knowledge proofs about essentially being a real human being that's verified by an orb. And essentially what you're able to do is that you're creating zero knowledge proofs locally on your mobile phone, and you never reveal any sensitive or public information or any private information to the chain. In this case, when you're generating a world ID, you get a private and public key pair. You have essentially this representation of your eye called an iris code that's stored inside of a smart contract, inside of a Merkle tree. And this is like a pseudonymous random string of bits. And you're able to essentially prove that your iris code is indeed in the smart contract. And this essentially allows you to prove personhood. Another thing that you can do is essentially verify that it's a unique person doing these things by having this private signature that signs these transactions associated with the zero knowledge proof. And this essentially obscures which iris code or which pseudonymous string of bits is signing or verifying a proof of personhood. If you associate this with an action, let's say like voting inside of a DeFi protocol governance proposal, for example, you're able to essentially prove that you're unique and that you haven't done an action before. But for the context of ZKML specifically, when a user is getting onboarded, the way that you generate this unique privacy-preserving identifier is by using ML, right? So you take an image using our custom-built hardware device called the Orb, and this hardware device then runs a bunch of checks to prove that you're human. And after that, it creates like a unique bit of strings for each person, and you submit this string to the smart contract. So if you want a user to, instead of having to rely on the orb to compute this identifier, you're able to sort of just take an image with an orb once, the orb signs the image with its private key, and you're able to self-host this biometric information on your phone in an encrypted manner, and you'd be essentially able to generate your own world ID locally inside of a zero-knowledge proof, as long as you have a zero-knowledge proving library that's able to prove the iris code generation, and then just submit your newly created iris code alongside with the proof to the World ID protocol, and you'll be able to create a new identity. And if ever comes the case that a new model comes along that's more performant, more scalable, more inclusive, faster, any of many improvements, possible improvements, you'd be able to recompute your iris code without having to go to this hardware device again. That's like one of the better use cases for ZKML that we can think of inside of Worldcoin. But part of this is that you'd be having to create a zero-knowledge proof of this really expensive computation, it being an ML model, in a very computationally constrained environment, it being the mobile device of a user that may have a 32-bit Android phone, which may have like very small amounts of RAM memory for computing these proofs.
Cool. Very good. Yeah, no, it's super exciting. And I like the thought. I go back to the work Modulus is doing around efficiency of proof system and the environments we can run in. Jason's comment around let's think of the use cases and then figure out how to solve them from a scale perspective. But yeah, we could have a super long Twitter space, I think, on this topic, but we probably should shift gears to take a few audience questions. We did have a few that came in, and I will just read those as they are, and then whomever on the panel wants to pick them up could. So the first one is coming from Chesley. It says, "How is ZK used in fraud prevention?" So I think it's more of a ZK general question, but I think there's some ML application there as well. So yeah, I'll just throw that out. How is ZK used in fraud prevention?
I can take a stab at it. So,
yeah, go ahead.
Yeah, so I think the fundamental, or one of the fundamental guarantees that ZK gets us is effectively that of validity. Not to take y'all through too much of history, but some of the original kind of practical zero-knowledge proofs or sort of zero-knowledge snarks were actually developed by Microsoft back in 2012 and 2013, basically GPR12/Pinocchio. And the whole point there was that Microsoft was a little worried back in the day that since Azure was a brand new cloud service, that folks wouldn't trust Azure, that basically you were outsourcing your compute to this totally untrusted execution environment, and that if Azure wanted to cheat, if they wanted to run a different algorithm, if they wanted to, for example, in the fraud case, not run the fraud algorithm that you care about, but rather a modified fraud algorithm, which does allow some transactions through which are fraudulent because they were bribed or something like that, that they would be able to do. And effectively what ZK gets you in this case is it allows you to show that the same fraud algorithm is being used each time, right? That there's no way that anyone can basically tamper with this or can basically, or as Daniel was saying earlier, that basically the operator of this fraud model has thrown away the keys. And the only thing left for them to do is to operate such a model, in the sense that basically you would like to do fraud detection via machine learning. You would like to know that the fraud detection model itself / the person who is running the model cannot be tampered with or cannot tamper with the model. And that is what the ZK validity gets you.
Excellent answer. Anyone else have anything to add on that? That was an excellent summary.
I can also give a little bit more context. In the context of smart contracts, so smart contracts are sort of these programs that run on top of this network. Let's say it be Ethereum, and let's say that there's a smart contract which has some state. Let's say the state of balances of all tokens that are deposited into the smart contract. If I am able to prove to the smart contract that I am able to create a state transition on Ethereum, which transfers all the tokens to me, then I can essentially prove an exploit. I can prove that I'm able to take this smart contract to a state which would mean that it's being exploited or it's exploited. If there's some sort of rule set to define what it means to be exploited, let's say withdraw big parts of the deposits, somebody would, like a white hat sort of security person, would be able to prove to the smart contract that, hey, you have a vulnerability, I'm able to exploit like a big portion of your funds and just extract them to myself. The protocol could be automatically frozen, or like some emergent piece of code could kick in and override these things to disallow withdrawals and like trigger an upgrade to revoke all permissions and just give the funds back to the users. There's a lot of things you could do like this, just proving exploits using ZK, right? Like creating a zero-knowledge proof of an invalid state transition, thus proving an exploit to someone, which would prevent fraud in this case.
Cool. Very good. Excellent answer. Okay, next question comes from Nathan. It says, for situations where an operation has been proven, what kind of UX experience do you imagine for users to understand an operation has been proven? Would this be wallet side, site side, which I assume means host side, and accepted standard or protocol on chain? So again, for situations where an operation has been proven, what kind of UX do you imagine for users to understand an operation has been proven? So anybody want to take that or any thoughts?
No, I think that's an excellent question. And actually, so in case one, we've proven an operation to the chain and the verifier is running on chain, then it's very easy because the action that's fired off by the fact that the proof went through and the execution of the model, the inference was proved, is recorded on chain, results in a successful transaction. I think in the other case where we're using this for sort of general enterprise purposes, or the TSA trying to prove that our screening algorithm is fair, or we're screening CVs and trying to prove it's fair, it's a really good question. And it's really a deep question of how does, if you get a green check mark, how do you believe that green check mark is correctly computed if you're, say, a non-technical user? And that part, I think I don't have a good answer to, but it's a really good thing for us to think about collectively.
Yeah, it's definitely an excellent question. And I think the UX around it is, I think, to be defined up to the application as multiple choice. The key being decentralized, settled on chain in some fashion. So that means it can be verified in whatever application setting you're in, I think is a key. So we're actually bumping up on time. It's been an hour. That was really a quick hour, actually. So I really enjoyed the conversation and hope everyone did as well. But I want to first of all, thank the speakers. Thank everyone for taking time out of their day to join the conversation and talk with us a bit. Thanks everyone for joining the Twitter space. Appreciate all your participation and questions and everything. This will be recorded, so we'll have it out there later. If you're looking to learn more or get involved, there's several good resources out there. One, there is a Telegram group called ZKML Community. It's a great place to pop in, learn things, ask questions. And then also on GitHub, there's an org called ZKML-community. And there's a repo under that called awesome-ZKML, which has just a ton of great learning resources on ZKML. And yeah, if you have any to contribute, we'd love to have those in there also. But again, thank you so much for everyone that joined us. Speakers, great catching up with a number of you again. And I look forward to talking soon.
Thank you so much, everyone. And hey, massive kudos to DCBuilder here for organizing the ZKML community.
Yes.
A lot of that is spearheaded by DC. So
absolutely.
Go team.
Yep. Hands off. Yeah.
Thank you.
Great work, DC. Yeah. All right. Thanks, everyone. Have a great day.
Have a great day. Bye-bye.